Okay, sorry if this video gets to you late. I actually just zoned out last night, but enough talk. So remember that real roots are individual roots, but whenever you get complex roots, they always come in pairs. You have the positive and the negative complex answer. So if we look at number 4 here, notice we have a 4, a -1, square root 10. They're all regular, real kind of roots. So I know that this most likely is a cubic function because it's basically going to be x minus 4 times x plus 1 times x minus square root of 10. Okay? And I'm trying to think, does that square root mean it comes in pairs or not? Because usually square roots can be positive or negative. So that may be something you want to ask your teacher. Is x plus square root 10 also another root? So that's the big question mark I want you to clear up. Okay, now number 5 here. Notice we have a -5, so we're going to do x plus 5 because -5 plus 5 is 0, right? The 2i definitely comes in pairs. We'll have the x plus 2i, but also times that with the x minus 2i. Put these all in a string, right? All side by side each other. And the negative square root 2 is x plus square root 2. So the question mark again, do I also say x minus square root 2? I would not do this until you clear it with your teacher. Normally, real roots come individually, so, but just get that cleared up with your teacher, okay? Now let's look at number 6 here. The 5 means x minus 5, because 5 minus 5 is 0. Minus 2 means x plus 2, because -2 plus 2 is 0. Now I have a complex. So I'm going to do x plus 3 minus I and x minus 3 minus I. Okay. Let's see here. If I distribute the minus, I think that becomes a plus though, right? See, I just want to make sure you understand that I'm going to do a plus 3 minus I, but I'm also going to do a minus 3 minus I, and the minus distributes to make that a plus I. So just in case you're wondering what I was thinking there. And then we have 6 plus square root 7. So that would be x minus 6 minus square root 7. Again, what I did is I had to distribute the minus there. So in that case, coming back here, if I did a plus, distributing the plus, it would not change the minus I. So that hopefully is it. But again, my only question mark is, should we also do a plus square root 7 as well? Okay? So that's basically what you're getting at with these kind of problems. Now, does your teacher also want you to throw a unknown constant a in front? Because we don't know what that constant could be, right? That'd be a second question I would definitely ask my teacher quickly before any quiz or exam starts. Okay, let's see here. Let's go ahead and duplicate page here. Let's go ahead and clear the ink. There we go. And now what do we have here? So number 7, let me actually duplicate this a few times here. Okay, so there we go. There's that work. Okay, for number 7, what do we have here? So notice we have a double or square there. That means that one's going to bounce. Okay, so let's first find our zeros. So here, 0 for x makes the whole thing 0. Here, 4 minus 4 makes it a 0. Here, -2 plus 2 makes it a 0. But notice it's squared, so this one's called a double root. Double. And here, -5 plus 5 would make it 0. So I have 0, 4, -5. Those multiplicities are 1. And then I have the -2. Its multiplicity is 2. Okay, so that's what you would fill in here. You'd fill in those 4 different roots. But this one's the -2, right? Because it's a double root. It's going to bounce in our graph. Okay, so let me just make sure I didn't miss anything. All right, it wants the x-intercept, it wants the degree. Well, if it's 1, 1, 1, 2, that adds up to 3, 4, 5. So we know our degree has got to be at least 5, right? The y-intercept we're going to figure out when we plug in 0 for x. Okay? The sine of LC. What the hell is LC? I have to be honest. If I knew what LC stood for, I could help you on that one. Leading coefficient. The sign of the leading coefficient. Well, it looks like it's negative, right? -1. Okay? So we have a -1 in front, correct? So the leading coefficient is a negative. It's a -1. Okay, we'll talk about M behavior once we do the graph. So let's set up the graph here. And we know we have a 0 at 0. I'm going to make my dots extra big here. So we have a 0 at 0 there, right? We have a 0 at 4. We have a 0 at -5. And we have a 0 here of -2. But remember, that one is going to bounce from there. The other ones are going to slash through. So, because it's a negative and we know it's x5, right? Our degree is 5. We know our function normally would look like this. That's what odd functions look. But because of the negative, it's going to go in the reverse order. It's going to look like this. Okay? So, the best thing to do now, though, is pick a number to the left of -5, your furthest left root, and see whether it's up or down. It should be up here, as predicted here. But we ought to verify. Now, one thing hopefully your teacher showed you is you could just plug it in its factored form here. So if I plug in, I'm just going to pick -6. I'm going to have the negative of -6. Okay? -6 in there means -10. -6 in here, but it's squared. So it's going to be a positive. Let's see here. What's 16, right? -6 in here would be a -1. So we have a negative times a negative, positive times a negative, negative times another negative, positive. So see, it's going to be positive something up here. So now I know basically it's going to go down like this. It's going to bounce off the -2. And it should, this is going to be interesting. I guess we're going to have to curl back up, back through. And yeah, it's going to go, that's right, it's going to go down like that. So remember, its overall shape should look like this here. Okay? Up on the left, down when it goes on the right. So we just answered the last question. Over here, when x goes to -infinity, that's this right here, we know it's going to positive infinity. And when x goes to positive infinity, we know it's going to go to negative infinity. Because again, a negative odd function looks like that. Now, the only thing I didn't answer was y-intercept. So what we're going to do here is we're going to, actually, we already figured that out. When we plug in 0, we get 0. So the y-intercept is at 0, 0. Okay? Again, when I plug in the 0 right there, that negative x, when that's -0, which is 0, it's going to times all the rest of these, and it's going to still make it 0. So hopefully this is helping. I'm trying my best to get this done before school starts. So please let me know if you have any questions. Come by in the morning, okay? Go to the bathroom first period or second period, and then come see me if you have questions. You got it? All right.